All right, good afternoon, class. We're going to go over these exercises today, and 1 through 4 ask us to find if y is a function of x, right?
Yeah.
So let's go over these problems. What would you say about problem number 1? Do you think y is a function of x?
Yes.
Yes, how do you know that?
Because it passes the vertical line test.
Put it in
Oh.
the cap.
Okay, so you actually put it in the calculator and saw that
There
it
won't
passed
be
the
two of the
vertical
same.
line test? Pardon me?
Because there won't be two of the same x with that equation.
Yeah, so that's right. And one thing we did in fifth period today is we actually made a table and we tried different points, right? And if you try 0, you have undefined, right? What does DNE stand for? What does DNE stand for? DNE. What does DNE stand for?
Do not enter.
Almost, not
Was
is
it in your
right.
video?
I think it is. Does not exist. Okay, does not exist. And really the function starts existing at 4. And we have 0, 5, 1, 6. We have 6 minus 4, square root of 2. And if we plug in 8, what's 8 minus 4? 4. Square root of 4 is 2. And so if you go ahead and graph this out, you get at 4, you get something that looks like this, right?
Yeah.
And what kind of function is that? What is the parent function of this? What's the parent function of this?
Y equals x squared. The y equals square root of x.
Y equals square root of x. So basically what you're doing is you're taking this parent function right here, and what are you doing with it? You're just translating it 4 units to the right, okay? And yes, pass the vertical line test, so numerically, graphically, and also just your understanding. If you understand what a square root equation does, you'll know the answer too, right? So there are a lot of different ways. So yes, and as Emily said, I'll say yes. And we could say, for one thing, we know it passes the vertical line test, right? So that's one way we can verify that. Okay, let's go on to problem 2. We have y equals x squared plus or minus 3. Is y a function of x?
Yes.
Yes, Angel says.
I don't know.
You don't know? Okay, let's try this. Okay, we go here. We'll go xy, right? So if we plug in, I don't know, 0, what's y going to be? Well, it'll be plus or minus 3, right? If we plug in 1, what do we get? Plus or minus? Well, actually, for this one here, we get, what's 1 squared plus 3? 4. Or, what's 1 squared minus 3?
-2.
Negative 2, right? Is that right? Okay, yeah. Or, if we plug in 2, we would get 7, right? Because that'd be 4 plus 3. And what's 4 minus 3? Or 1. So is y a function of x? Let's look at this. Okay, if we plug in 0, we get plus or minus 3, right? If we plug in 1, we get 4 or negative 2. If we plug in 2, we get 7 or we get 1. Okay, so we get this looking thing here, and we get this looking thing here. Is y a function of x? No. And why not?
Because it doesn't pass the test.
Fails vertical line test. All right. Next, 3. For 3, is y a function of x?
Yes.
Yes, they say. How do we test it out? What do you want to do for this? What do you want to do to test if y is a function of x?
Graph it into the calculator.
Can you graph this in a calculator?
Oh, no.
Yeah,
Not like
to
that.
change.
Do it, convert it to what equals.
Oh,
Convert to y equals. Let's convert to y equals. How do we do that?
divide by 2 and then square root.
Divide by 2.
When you
So
do the
now we-
square root first,
Yeah, square root.
order of operations. Oh, yeah, square root and then divide by 2.
Let's talk about that. Would we take the square root first?
Yes, yeah.
Let's experiment on that. If we did x equals 2, if we take the square root of first, then we have square root of x equals square root of 2 y squared. We could do that, right? Then what?
Divide by square root 2.
Then divide by square root of 2. Then divide by, well, actually this is going to be y here, right? But what did when we took the square root of y squared, what do we have to do over here? This canceled out here, right? What do we have to do here? Let's just, this is one way of doing it. Yes, we could take the square root first. Usually you'll go ahead and isolate y squared before you'll do it, right? But you can do, this way is a valid way of doing it. But now if we take a square root, we get y equals square root of x over 2, right? Is that right?
Yes.
Are you sure that's right? Are you sure that's right?
I
I
mean,
think it's right. Looks right.
it's about the same as the other answer.
Okay, think back all the way to yesterday.
That's a far, that's a long time ago.
Well, you gave me the answer yesterday to this.
No pressure.
Will gave me the answer to this concept yesterday.
What'd you ask?
Get Emily.
Is that correct?
I think Mr. Greiger knows.
Yeah, you should ask Mr.
Adam,
Greiger.
you know this one.
And he's
I
answered
don't
Okay, I know when I write it down, you're gonna just say, oh, come on, how did I not know that? Okay, watch this.
Oh, my.
Oh, come on, how did I not know that?
Will.
Am I right? See, Will knew this, he knew this yesterday, but didn't today. No, but what it is, it's about context a lot of times. Because you may not have remembered the context from yesterday, it applies more broadly here. So that's what it is. And so in this case, is y a function of x?
Yes.
Okay, let me graph this.
No.
Okay, here is positive square root of x over 2, and here is negative square root of x over 2. Is y a function of x? No, because it,
Doesn't pass the third one.
here we go. Oops, I meant to draw a separate one. Okay, let's see if I can do it this time. Okay. Does this pass the vertical line test? No. So we say no, fails vertical line test.
Mr. G, are you like on a live right now? or-
Well, yes, huh? This is a lot. Well, you're not live, but it's being recorded.
Oh.
Yeah, can you just
It's live when I upload the video later today. That's what it is. And I think I'll probably choose this class because you guys are so good. All right. And this one here is y a function of x.
Yes.
Okay, Will says yes. What do we have to do to figure out for sure? Let's go ahead and solve this. How we solve this one?
Y equals 12 minus X.
So Hannah came up with y equals 12 minus x. Actually, I think that's right. I don't know how she did it, but I think that's right. How'd you do that, Hannah?
I moved the 12 over and then.
So she moves y over here and this way, and she moves x this way. And so y over here becomes positive, right? And then x over here becomes negative. So you can do that. That's kind of a shortcut. But now, is y a function of x?
Yes.
Yes, it is. So yes. And we know this passes the vertical line test.
So
Okay?
whenever it's plus or minus, it's always going to be no. It doesn't.
Yeah, that's right. However we get plus or minus, because it's like going to a vending machine and you want to get Coke, but you don't know if when you press the button if you're going to get Sprite or Coke, right? So is that the kind of function you want? No, you want to make sure that when you press the Coke button you
I'd
get
rather
Coke.
get spread though.
You'd rather get, or when you press the Sprite button you get Sprite, or when you press Dr. Pepper, anybody Dr. Pepper fans here? Press Dr. Pepper button, you get Dr. Pepper, yeah. So we got some Dr. Pepper fans here. Got to be Dr. Pepper fans, we're in Texas. Okay, 5 through 8. 5 through 8, use the vertical line test to determine whether the curve is a graph of a function. So I draw a vertical line here. Is this the graph of a function? Yes. So yes passes vertical line test. Yeah, we're just going to do 1 through 10 today on this. This one here, function or not a function? Why, Adam? Why is it not?
It doesn't pass.
Thank you, Adam.
You're not me.
I'm sorry, you're not him. No.
So you're not.
Sorry. Somebody's brown.
Okay, good.
The way I usually just buy you.
All right. This one here, pass or fail vertical line test.
Yeah.
Besides, I'll practice it.
No.
No.
And
And then yes.
Yeah, I cracked one of my teeth doing that. One of my cousins bit me.
Okay.
Except she bit into it with her left teeth.
Yes, it is a function.
It's a function.
Okay. So how do we know that? Pass the vertical line test. It doesn't look quite right because my line isn't actually vertical, right? So let's say yes. Now, in fifth period, they didn't recognize this function. Do you recognize this parent function here?
Yes, we don't remember the name.
Y equals negative n.
Almost, okay. Will almost said it. It's going to be y.
Execute.
It's y equals x to the negative 1 power, which is the same as 1 over x.
I said good try.
Well, 1 over x. No, that's it. That's the parent function, but this is translated from that. Okay?
Yes.
That's all. Okay? Okay, and also, we're going to do 9 and 10 on the front side here.
Two more.
So this one right here, we want to find the domain. That's what we're trying to find, the domain of the function algebraically. What is the domain of this function here?
Negative.
Domain.
Negative infinity is less than x is less than positive infinity.
Yeah, and so what happens is Kayla says like this, right? Is this what you're saying, Kayla? Is that what it says? Yeah, that's exactly right. One thing we're gonna do in this class is, we were introduced last year to interval notation, and 90% of the time, we're going to be using interval notation. So how would we rewrite Kayla's?
Put the parentheses, negative infinity, comma, infinity, parentheses.
Yes, yes.
Too bad.
Oh, yeah, yeah.
And how did you know that the domain has all real numbers? That's what you say, all real numbers.
Or do the little
Isn't it that, like that R?
Yep.
Weird R?
Yeah, you can also do what they call this kind of script R,
Yeah.
all real numbers, right? How did you know that it was all real numbers?
Because if it's a function,
Okay,
it's a function that it can be a real number.
If it's a function, it can be all real numbers, right? So that's one thing. And normally, for most functions, the domain is going to be all real numbers. Now, in the case of problem 8, is this an all real numbers domain here?
No.
No, it's not, because you have this vertical asymptote. By the way, you see the vertical asymptote on my shirt here? All right. And so, Kayla's right. What kind of function is this? We call it a certain type of function. And what kind of function?
Quadratic.
A quadratic function, right? And very good. And a quadratic function is from what family, what larger family of functions?
That one.
Polynomial functions, exactly. So, yes, family of polynomial functions, and the domain of all polynomial functions is all real numbers. And so by the very type of function, understanding what it is. But I'm like Kayla, that if somebody asked me if I think a certain function that I don't know yet is has a domain of all real numbers, I would just guess it was, because most are. Now this one right here, what is the domain of this function here? Also it says test graphically. We're going to look at that too. What is our domain of this function?
And has a negative infinity.
Okay, so negative infinity, like this, Kaylee, okay. Okay, so that's like the start, right? So what do we go up to here? 3? Okay, 3, and then what?
U.
Oh, U? Like this? Yes, this right here
Well, would the parenthesis by the 3
Is
be
it
a
union?
bracket or a 3? Is it
is called a
Union.
union.
Yin.
Okay, Emily, she's probably watching the video there. No, I know she's not.
No, I watched it last night.
Oh, from the other video I gave you, which had this, or something like it.
Oh, she did it. She's fine. She just thought.
I believe Emily. All right, I believe Emily.
Up with the U.
I paid.
Okay, and then, so that's going to be our answer. And it says support graphically. We support graphically. We can go to our calculator.
I can see clearly.
We can go to 5. And x minus 3, right?
Yes.
And then we graph the function. Looks like this. So it looks kind of like this, except on my shirt the vertical asymptote is x equals 2. But it's the same concept.
You can help us with the ones on the back, Mr. D?
We'll be doing those tomorrow.
Okay.
Yeah.
We're done for the day?
So we'll be doing that. So that's as far as we want to go today. So good class today.